Welcome to my YouTube channel. Let us solve one more example on shear force and bending moment for overhanging beam. To determine support reactions, our first step, that is to determine support reactions. Okay, this is our beam. What about the support? The support is hinge support, right? So what about the reactions? Reactions are two, horizontal and vertical. This one is roller support, so reaction is 1, right? Now let us determine reactions. This one is our equilibrium condition. Algebraic sum of all forces in x direction is equal to 0. Here right side is positive, left side is negative. Here we have only one horizontal force, right? So we don't have any other horizontal force. So horizontal reaction at A is equal to 0. Next, algebraic sum of all forces in y direction is equal to 0. Starting with this UDL, in 1 meter we have 5 kilonewtons. So total load is 5 into 1. Acting downwards, so negative. Again reaction at A, acting upwards, positive. -7 minus 10 plus RB minus 8 into 1.5 is equal to 0. So here we get RA plus RB is equal to 34 kilonewton. Next, let us move on for the next equilibrium condition, that is algebraic sum of all moments about any point is equal to 0. Right now we are taking moment about A point, right? So here the line of action of these two forces are passing through A point only, so we don't have any distance from A point, right? So RA into 0 and HX into 0, right? Now next, what about the moment of this UDL, and where is the CG of UDL? CG of UDL, that is at the half span of the UDL length. What about the UDL length? UDL length is 1 meter, right? So CG will act at 0.5 meter, right? So 5 into 1, that is total load, and 0.5, that is perpendicular distance from A point. And what about the nature of moment? Nature of moment is anti-clockwise, that's why negative. Here clockwise is positive and anti-clockwise is negative, right? Now moment of this force is 7 into 1, and clockwise moment of this force is 10 into 2. Again it is also clockwise about A point. Okay, now next, distance of this RB from A point, that is 2 plus 1 plus 1, that is 4. And what about the nature of moment? Nature of moment is anti-clockwise. Now for this UDL, right, what about the perpendicular distance from A point? From the CG to A point, what about the distance? Distance is 0.75 plus 4, right? And the nature of moment is clockwise, right? So 8 into 1.5, that is total load. 4 plus 0.75, that is perpendicular distance from A point, and the nature of moment is clockwise, right? So that's why positive is equal to 0. From this we get RB, and from the previous equation we will get RA also, right? So we get all three reactions. Now let us determine shear values. Okay, before we move on to the shear values, we should know what is shear force. Shear force is the algebraic sum of vertical forces either at the left or at the right of section, right? Here we have to take section, right? So these all are our reactions. Let us take a section at C, right? Section at A, section at E, section at F also. Now let us consider the left part. Okay, what about the shear at C? If you consider left, do you have any vertical force in the left side of C point? We don't have any vertical force, so shear at C is equal to 0. If you move on to the A point, and if you look at just left part of this A point, what we have? 5 into 1. And if you move just right of A, but remember you have to consider left part only. You're moving to just left of A point and just right of A point, but we are considering only and only left part, right? So if we move just left of A point, what about the value of load? That is 5 into 1, and it is acting downwards, so it is negative. Now let us move to the just right of A point over here. So now we have to consider two loads. One is UDL, another one is reaction also, right? So 5 into 1, that is UDL, plus 13.62, that is reaction at A. So what about the what about the shear force at A? In the just right of point A, it is 8.62 kilonewton. Now what about the shear at E? Shear at E, up till A point we have already calculated shear and the value is 8.62. So no need to calculate again, right? So 8.62 minus 7 because downwards, so it is 1.62. Up till E point the value is 1.62, right? So what about the shear at F? Shear at F is 1.62 minus 10 because 10 is acting downwards, so it is minus 8.38. Now what about the shear at B? What about the shear at B? Up till F point the value is minus 8.38. So in just left of point B the value is minus 8.38. If we move at just right of point B, now we have to consider this reaction also, right? So minus 8.38 plus 20.3, the value is 12, right? And what about the shear at D? 12 minus 12 because 8 into 1.5, that is 12 only, right? So 12 minus 8 into 1.5, that is 12, is equal to 0. So shear at D is 0, right? Now let us draw diagram, but before that, what about the representation of shear force? If you have a point load, then definitely you will have vertical line, right? If you have UDL, then you will get inclined line, okay? And uniformly varying load, that you have to show by second degree parabolic curve, and if you don't have any load, then it shows horizontal line, okay? Let us draw the diagram. These are our values. This one is the line, right? Now what about this line? Above this line we have positive values and below this line we have negative values. Let us start with the C point. At C point we don't have any shear, so value is 0. Shear at A we have two values, one is minus 5, another one is 8.62. So minus 5, and in this span you have UDL, so you have to represent the same by 5, inclined line. So 0 to 5 inclined line, right? Now at A point we have second value also, 8.62 positive, so 8.62 positive, right? And at A point you have vertical load, then you have a vertical line also. And between A to E, do you have any load? We don't have any load, right? So in between A to E we have constant value of 8.62 and it will be represented by horizontal line. At E again we have value 1.62, right? So at E the value is positive 1.62. Again up to E to F you have this same values, okay? We don't have any other load, so constant diagram, horizontal line 1.62. Again F we have the value is minus 8.38, right? So the value is minus 8.38. In between F to B the value is constant, minus 8.38. Again at B you have the value positive 12, right? So the value is positive 12. Again at B point you have a vertical load, so you will have vertical line, right? Now at B point, what about the value? The value is, at D point, what about the value? Value is 0, right? Value is 0, okay? In between B to D you have UDL, so you will have inclined line, right? At D point the value is 0, okay? So this is about the shear force diagram: negative shear, positive shear, negative shear and positive shear. Now let us draw bending moment diagram, but before that let us determine the bending values. What about the bending moment at C? If you consider the left part of section, we don't have anything, and as well as C is free support, so free support don't take any moment, so bending moment at C is 0. Here our assumed sign convention is clockwise positive and anti-clockwise negative. Let us start with the bending moment at A. What about the bending moment at A? If we consider the left part of portion, phi into 1 and the perpendicular distance is 0.5, and what about the nature of moment? Nature of moment is anti-clockwise, so minus 2.5. Here phi into 1 is total load and 0.5 is the perpendicular distance from A point, right? Now bending moment at E. Now we have to take moment of these all forces whichever is there in the left part about E point, right? So starting with the 5 kilonewton, 5 into 1, that is total load. And what about the perpendicular distance from E point? 0.5 plus 1, right? And what about the nature of moment? Anti-clockwise. And moment of this reaction about E point, that is 13.62 into 1, and it is clockwise, right? Moment of this UDL is anti-clockwise about E. Moment of this reaction is clockwise about E. But as we are taking section at E, you have to take moment of all forces either in the left part or in the right part about E point only. Remember this thing, okay? Now let us take the moment about F. If we consider the left part only, what about the forces involved? The forces are 5 kilonewton, this reaction, this 7 kilonewton. So we have to take moment of all these forces about F point, right? So starting with this 5 into 1, that is total UDL, multiply by the perpendicular distance is 1 plus 0.5, where is the CG of UDL? So that is 2 plus 0.5, and nature is anti-clockwise about F point. Moment of this reaction is 13.62 into 2, and again it is clockwise in nature, right? Then for this 7 kilonewton, 7 into 1, and it is anti-clockwise in nature, right? So this is about the bending moment at F. So the total moment is positive 7.74. Now if I take section over here at B, either I can consider left part or I can consider right part. But which one is convenient to us? Right part is convenient, because in right part we have only one force. So we have to take moment of only one force. Okay. The result will be the same. Either you consider left or you consider right. You will get the same moment, right? So let us consider the right part. So considering the right part, what about the moment? Moment is minus 8 into 1.5 into 0.75. Okay. So considering the right part, the moment is minus 12 kilonewton into meter, and as it is a clockwise, right? It is clockwise. In right part, clockwise moment is negative. Remember this thing. In right part, clockwise moment is negative, right? And how it is? You can see my lecture of sagging and hogging bending moment. You will get how it is negative, right? So in right part, the clockwise moment is negative, so it is minus 12. And bending moment at D is 0 because it is free support. Now for the representation of diagram, if you don't have any load, represented by inclined line. For UDL, it is represented by parabolic curve of second degree. For UVL, it is cubic curve of third degree, and for the moment it is vertical line. Let us draw diagram positive value above the line and negative value below the line. Let us start with the bending values. Bending values are bending moment at C is 0. So 0. Then bending moment at A is minus 2.5. So bending moment changes from 0 to minus 2.5. In between you have UDL. So it is represented by parabolic curve. Okay. Then bending moment at A is minus 2.5. What about the bending moment at E? It is 6.12. So the value changes from minus 2.5 to 6.12, and in between we don't have any load, so it is represented by inclined line only. Now what about the value at F? It is 7.74 positive, right? Value at B is minus 12. It is negative, right? And what about the value of D? It is 0. Again in between B to D we have UDL, so it is represented by parabolic curve, right? Negative values and positive values. And what about these 2 points? These 2 points are where bending moment is 0. It is point of contraflexor, right? Where the bending moment changes its sign from negative to positive, right? So that's why it is called as contraflexor, right? Or you can say the bending moment is 0 at these 2 points, right? I hope, my dear students, you don't have any query, any questions. If you have any query, please mail me at structurelengineeringconcept@gmail.com, and please don't forget to like, share and subscribe.